Now let us proceed to the second major activity in this lesson, which is to determine the general term for each of the following sequences. So this is the reverse process. In the first major activity, where we're given the general terms and we solve for the terms of the sequence. This time, we are given the terms of the sequence and we're going to determine the general terms. And let's start with number 1. Given the infinite sequence, 5, 6, 7, and so on. It is infinite because of the presence of ellipses, meaning so on. What is the general term? To do it, you start with writing the terms and the given. For the terms represent your n. And what are the terms? How many terms are there? You count the known terms. You have 1, 2, 3. So your values of n are 1, 2, and 3. And while your values of your a sub n are 5, 6, and 7. Let me remind you that your n is your independent variable. So this is our independent. While your a sub n is your dependent. So, this is very important that you know the independent and the dependent variables. It is because it is the independent variable that we're going to manipulate in order to produce the dependent variable. So how are we going to solve it? To solve for the general term. You focus on your n, your value of n. So your n is equal to 1. And your next question is, what are you going to do with your n in order to produce 5? So you have to produce 5. What will you do with your n to produce 5? So you might say, I am going to add 4. 1 plus 4 is equal to 5, right? This is true for the first term. Let us check if it's still true to the second term. So what is your second value of n? 2. We need to produce 6. Let us check if adding 4 will give us 6. 2 plus 4. Is it equal to 6? The answer is yes. So that means adding 4 to your n is true for the first term and the second term. Now let's proceed to the third term. What is your third value of n? You have 3. Then plus 4, because that is what you're adding, is equal to 7. And it's true, right? Therefore, our general term will be, you write, a sub n is equal to 1, 2, and 3. These are your values of n. So you will write n, then you added 4 to all. Because if you will say general term, that means it is true to all. So, plus 4 is your general term. Let us consider the finite sequence. 4, 7, 10, 13, and 16. It is finite because it has a last term, 16. Okay? So what are your values of n? Your values of n are 1, 2, 3, 4, and 5. And what are your values of your a sub n? You have 4, 7, 10, 13, and 16. Again, just how we did it, just like how we did it in our first example, number 1, we will focus on your n. So your n is 1, and it should give us 4. Okay, so your first question is, what will you do with your n to give us 4? So, you will be adding something to your 1 to make it 4, right? So, you will add, what number are you going to add to your 1 to get 4? That is 3. It is true to the first term. Now let us check if it is still true to the second term. So your n is 2 plus 3, because that is what we did in number 1, is equal to 7. Is it equal to 7? 2 plus 3 is equal to 7? The answer is no, it's not equal to 7. Meaning, adding 3 to your n is not true to the second term. Therefore, adding 3 to your n is not true for the second term, because 2 plus 3 is just 5, which is not equal to 7. So in this case, adding 3 is not the solution that we're looking for. But you cannot also have adding 4, because it will exceed. 4 plus 1 is 5. You cannot also add number less than 3, because 1 plus 2 is 3. You are short by 1. You cannot also proceed to subtraction, because when you will subtract a number from 1, it will give you negative. So meaning, addition and subtraction operations will not anymore work. So proceed to multiplication. You proceed to multiplication, because we're done with addition and subtraction is not allowed, so proceed to multiplication. I'm going to erase this. Okay. Let's go back to the first term. What will you do with your n to get 4? The operation now is multiplication. So, you can say, I am going to multiply it by 4, right? That is the easiest way to say it. Okay, let's try. We multiply it by 4. 1 times 4 is 4. Now, see to the second term, your second value of n. 2 times 4 is equal to 7. 2 times 4 is 8, which is not equal to 7. Therefore, multiplying it by 4 is not the solution. Okay. So let's go back to your n. What will be multiplied to your n? So we're done with addition. Subtraction is not allowed. Multiplication, we have restarted multiplication, but it doesn't work. However, in this case, we can say that there will be a combination of 2 or more operations. Try to think. If you multiply it by a number and you add another number, that will give you 4. Let's try 3. Or you can multiply it by, you start with 1. You multiply it with 1. So 1 times 1 is 1. Plus 3 equals 4. Let us try if it works for the second term. Times 1 plus 3. Let us try. 2 times 1 is 2, plus 3 is 5. It's not equal to 7. Therefore, multiplying it by 1 is not the answer. How about if we multiply it by 2? If we multiply it by 2, 1 times 2 is 2. So how much are you going to add to get 4? So multiply it by 2, then plus 2. 1 times 2 is 2, plus 2 is 4. So let's proceed to the second term. 2 times 2 plus 2. You copy. These are your values of n. 2 times 2 is 4. Plus 2 is 6. It's not equal to 7. Therefore, multiplying it by 2 is not the solution. You proceed to multiplying it by 3. Okay, let us try. 1 times 3 is 3. How much do you need to add to get 4? So you add 1. Let us try for the second term. 2 times 3 plus 1. 2 times 3 is 6 plus 1 is 7. So it is true to the second term. Now let's proceed to the third term. 3 times 3 plus 1 is equal to 3 times 3 is 9 plus 1, 10. So it is still true to the third term. Let's proceed to the fourth term. 4 times 3 plus 1. 4 times 3 is 12 plus 1, 13. It's still true. Now let's try with the last term or last value of n. 5 times 3 plus 1 equals 5 times 3, 15 plus 1, 16. Therefore, this is what we are looking for. We can now get the general term. So your a sub n is equal to 1, 2, 3, 4, and 5 are your values of your n, right? So your values of your n are multiplied by 3. So that is 3n. Okay? So you will write first your numerical coefficient 3. So 3n. You will not write n times 3 because n times 3 is 3n. So 3n, copy, plus 1. Because this is the rule that we are looking for. This one. Okay? So this should be true to all the terms. The third example, 3, 5, 9, and so on. Let us solve the general term of the given infinite sequence. It's infinite because we don't have a last term. The last term is not known. So what are your values of n considering the given? Your values of n are 1, 2, and 3 because there are 3 known terms. 1, 2, 3. Your values of your a sub n are 3, 5, 9. So let's start solving. You write your 1 here. Your equal is 3. So, what are we going to do with our 1 to get 3? Of course, we'll start with addition. So 1 plus 2 is equal to 3. Now let us check if plus 2 is true to all. Proceed to the second term. 2, so you copy your n2, then copy this, plus 2 is equal to 5. 2 plus 2 is 4, and therefore it is not equal to 5. Right? So that means addition is not applicable. We cannot also apply here subtraction because 1 minus any number will give us 0. If you start with 1 minus any number greater than 1 is negative, will give us a negative result. Therefore, subtraction is not applicable here. Proceed to multiplication. So what are you going to multiply with your 1 to get 3? So you will say, I will multiply it by 3. Okay? 1 times 3 is 3, and that's true. Let's proceed to the second term, if it's true. 2 times 3. Okay? Times 3. These are your values of n. is equal to 5. 5 is your a sub n. Is 2 times 3 equal to 5? The answer is no. Because 2 times 3 is 6. Therefore, multiplication is not also the solution here. That means there will be a combination of operations. Combination of operations. So, most probably, you will be multiplying it with a number and then add with another number. So, let's start with multiplying it by 1. So, 1 times 1 is 1 times 1 is 1. So, you'll have plus 2 to get 3. Let us check if it's true for the second term. 2 times 1 plus 2 is equal to 5. 2 times 1 is 2, plus 2 is not equal to 5 because it is 4. Okay? Therefore, multiplying it by 1, adding 2 is not the solution. So proceed to multiplying it by 2. You multiply it by 2, and then you are going to add. 1 times 2 is 2. How much do you need to add? 1 is equal to 3. So let's try with the second term. 2 times 2 plus 1 is equal to 5. Is it true? 2 times 2 is 4 plus 1 is equal to 5. Yes, it's correct. Let's proceed to the third term. 3 times 2 plus 1. 3 times 2 is 6 plus 1 is 7. Therefore, it is not equal to 9. So, multiplying it by 2, adding 1 is just true to the first and the second term. Therefore, it's not what we are looking for. Erase. So, this is really the hard part here because you really need to trial and error. So, 1 times 3 is not applicable. Therefore, it is not multiplication. If it is not multiplication, you proceed to division. But obviously, we cannot use division here if you will use your common sense. Because division will have to produce smaller numbers. So, it's not really division. Because 1, 2, 3 here became 3, 5, 9. So, it's not really division. If it is not division, proceed to the next one, which is exponent. You have to entertain the thought of having exponents. So let us try if we'll consider exponents here. Copy 1. So, what will be your exponent of your 1 to get 3? So, any number that you will use as exponent of 1 will always give you 1. Even if you will have here 3, is still equal to 1. 1 to the exponent of 3 is still 1. So 1 plus 2 is 3. Let us check if it's worked in the second one. 2 to the exponent of 3 plus 2. 2 to the exponent of 3 is 8. Therefore, it's not the number that we're looking for. How about if we start here with 1? 1 to the exponent of 1 is 1. Plus 2 is 3. Then, 2 to the exponent of 1 is 2. Plus 2 is not equal to 5. Therefore, this is not what we're looking for. Let us try 2 here. 1 to the exponent of 2 is still 1. 1 plus 2 is 3. So check. How about here? 2 to the exponent of 2 is 4. Plus 2 is not equal to 5. Therefore, this is not what we are looking for. And if you will change this to 3, the more that it's not true to the second term, because it will become bigger and bigger than 5. So this is not what we are looking for. Okay? So you have to entertain the thought of having your n as the exponents. As the exponents. Okay? So let us try with this. We will not start with 1. Number 1. Okay? Any number raised to 1 raised to any number is still equal to 1. So disregard that. Proceed to 2. 2 to the exponent of your n. So, ang ginawa natin kanina, ang n ay hindi ginawa nating exponent. Ang ibang number ang ginawa nating exponent. Base ang n. Ngayon, gagawin natin, we will try to make n not as base, but as exponent. So, 2 to the exponent of 1 is 2. So, you will add 1 to get 3. Let us try the second one, second term. 2, you copy this. 2 to the exponent of your n. 2 plus 1 is equal to 2 square is 4. Plus 1, 5. Then next, 2 to the exponent of 3 plus 1 is equal to 2 to the exponent of 3 is 2 times 2, 4 times 2, 8. Plus 1, 9. There you have it, guys. We have already solved, or we have already found what we are looking for. So this time, you can now write your general term, which is equal to, copy, 2, and your n are this, 1, 2, and 3. So 2 to the exponent of n, because these are your n, 1, 2, 3, copy, plus 1. There you have it, guys. We're done with our lesson 1 of the first module, which is generating patterns. Points to remember. In determining the general term of given sequences, you have to do it, or you have to do the trial and error. You are going to use the 4 fundamental operations. You start with addition, then if it doesn't work to all the terms, proceed to subtraction, multiplication, division, and if not, to combination of operations. And if it still doesn't work, consider having your n as exponent or your n as base and the other numbers as exponent. Another points to remember, you have to focus on your values of n. Since your n is the independent variable, therefore it is your n that you're going to manipulate in order to get your a sub n. Thank you very much, grade 10 students, for bearing with me in this video lecture. Hope to see you in my next video. Don't forget to like, subscribe, and share this video to your friends. This video could be of help also to them. Thank you. Bye-bye.